In this video, we are going to be learning about types of energy. We've been learning about work. Work is actually a form of energy. When you do work, you are transferring energy to a body. Energy is defined as the ability to do work and/or cause a change. An example is a stretched slingshot has potential energy and it has the ability to do work. It has the potential to move the rock. Let's see this in a picture. So before the person pulled back on the slingshot, the rock was just here. They did work on the rock to bring it back. Remember, work is equal to force times distance. When they did work on the rock, they were adding potential energy to the system. So that goes with bullet point. When you are doing work, such as pulling back on the slingshot, you are transferring energy to a body. In this case, the body is the rock. Again, energy is the ability to do work and/or cause a change. In this case, the stretched slingshot has potential energy. Therefore, it has the ability to do work. In other words, it has the potential to move the rock. When this person lets go, the rock will move, in which case work is being done on the rock. There are many different types of energy. Energy is mainly broken up into two categories, mechanical and non-mechanical energy. Mechanical energy is the sum of an object's kinetic energy and all forms of potential energy. Mechanical energy can easily be seen. For example, if you throw a baseball, the baseball is moving, so it has kinetic energy. That movement can be easily seen. Non-mechanical energy is energy that cannot easily be seen, such as electrical, nuclear, and thermal energy. For example, thermal energy is energy from the movements of molecules. We cannot easily see the movements of molecules, therefore thermal energy is non-mechanical energy. Mechanical energy is broken up into basically two types of energy, kinetic and potential. Kinetic energy is defined as energy an object has because of its motion, and it's related to speed and mass. We will be learning the formula for kinetic energy in class. Potential energy is the energy associated with an object because of its position. There are two types of potential energy: gravitational potential energy and elastic potential energy. Gravitational potential energy is the energy an object possesses because of its height. So an object on top of a mountain would have a greater gravitational potential energy than an object simply sitting on top of a table. And that's because the one on the mountain is higher up. Elastic potential energy is energy stored when an elastic object is stretched or compressed. So that could be a spring or a rubber band or anything else that is elastic. The more something is stretched, the more energy there is that is stored. There's also many types of non-mechanical energy. It would be kind of impossible to list all types of non-mechanical energy, so on this slide I'm going to give you a few examples. Chemical energy is the potential for a substance to undergo a chemical reaction. Thermal energy is energy an object possesses because of the movement of its atoms. Nuclear energy is energy that comes from the nucleus of an atom. One example of nuclear energy is the sun is constantly giving off nuclear energy. Electrical energy is the presence and flow of an electric charge. Now recall from one of the previous slides that non-mechanical energy cannot be easily seen. We can't actually see the atoms changing around in a chemical reaction. With thermal energy, we can't actually see the movement of its atoms. With nuclear energy, we can't actually see the nucleus of atoms changing. And with electrical energy, we cannot actually see the electric charge, electrons, flowing. So again, non-mechanical energy cannot be easily seen. let's go over what types of energies these examples are, and you may be able to come up with even more examples. So a ball rolling on the floor, what types of energy will that example have? Well, it's going to have kinetic. It's going to have kinetic because it's moving. It also has a temperature, so it's going to have thermal energy. Can you come up with any other types of energy this ball might have? If you can, you should write them in your notes. Number 2, a ball flying through the air. Well, it's moving, so it's going to have kinetic energy. It will also have gravitational potential energy because it's not on the ground. It is at some temperature, so it will have thermal energy. And I think we pretty much covered everything. A cat sitting on top of a 3-meter high table. Well, the cat's just sitting there, so it doesn't really have kinetic energy. However, it is not on the ground, so it's going to have gravitational potential energy. And the cat is also at some temperature, so it'll have thermal energy. Also in the cat, there are chemical reactions constantly happening, so the cat probably has chemical energy as well. Lightning. Well, the first thing that comes to my mind is electrical energy. There's also probably some heat being created there, so I'm going to say thermal energy. And it probably has the possibility to cause chemical reactions, so I'm going to say chemical energy. A hot cup of tea. The first thing that comes to mind there would be thermal energy. Now, the cup of tea is probably not sitting on the ground, it's probably on a table, so it's going to have gravitational potential energy. It may have the possibility of chemical reactions, so maybe chemical energy. And if you can come up with any other types of energy that a hot cup of tea might have, you should write them down in your notes. A stretched rubber band. Well, the first thing that comes to mind there is elastic potential energy. Now, that rubber band is probably not on the ground, so it probably has gravitational potential energy. It is also at some temperature, so it has thermal energy. Last example, sunlight. Well, I just told you nuclear energy comes from the sun, so nuclear energy. There's also going to be thermal energy. There's probably some chemical energy. And there might be some gravitational potential energy in there too. So make sure that you do your summary for your Cornell notes.